Alright, we're going to take a look at how you can find a regression line in this video. We're going to focus on the Mayer line method. A couple other methods out there that we'll look at as well in other videos. So first off, a regression line is a line that best fits all of the points in a scatter plot. So the idea of a scatter plot is we've got two different variables that we're looking at. One's plotted on the x-axis, one on the y-axis, and we're using those values to create points, and each of the points is basically plotted onto our axes. And you can check out the video on correlation. We look at scatter plots and how you can use a scatter plot to help you estimate the correlation coefficient. And the problem with a scatter plot is usually everything doesn't fit perfectly into a nice line or in a nice pattern. Rather, things are a little bit all over the place. So a regression line is basically the line that best fits all of our points in a scatter plot. And again, it won't be a perfect line that hits all the points. There'll be some above and some below, but it's kind of our best judgment. And the advantage in doing a regression line is to allow us to make a prediction of one variable when we have a value for the other variable. Now, I commented about correlation earlier, and the correlation and regression line are very strongly connected. The stronger the correlation between two variables, then the more reliable that our prediction using the regression line will be. So if we've got a strong or reasonably strong correlation between two variables, then we'd look at doing a regression line because we should get a decent prediction. If our correlation coefficient, though, is very low and there's not much of a connection between the two variables, we probably wouldn't go about doing the regression line because our prediction isn't going to be very accurate. So kind of like what's the point? So let's take a look at the steps first for finding a Mayer line. Let's clear this off. All right, so we're gonna look at using the steps to solve a regression line question and focusing on the Mayer line method. So the first step that I have, same as I've had for most of the other ones, is that we have to identify it. So how do we identify this regression line question? Probably the most obvious is going to be asked to find a regression line. And again, the Mayer line method is one method you could use. More than likely, though, you're going to be asked to make a prediction or to estimate an unknown value. And that kind of hints that you're looking at creating this regression line. Again, the idea being here, we can't actually solve for it. It's not going to be a perfect match, but we can do our best prediction. Also note, you might be given a scatter plot or shown a two-variable distribution table. Same ideas as what we saw for correlation as well, where we're maybe given it or created a scatter plot, or again maybe given a table showing two different variables that are connected. So our second step is we're going to order our data from the lowest x value to the highest x value. And don't worry about your y's for now, just focus on your lowest and highest x values. And as an option, you can also draw a scatter plot. And some people, especially if you're a visual learner, really like to see the points in front of them. Other times people find it can be a bit of a time-consuming process and might prefer not to do it. So I'm actually not going to do the scatter plot in this video, but I do a scatter plot in the correlation video, so you can check that out if you're not quite sure about how to do a scatter plot. And when we do this, we usually exclude any outliers. An outlier is kind of a point that doesn't seem to fit the general pattern. So maybe I've got a whole bunch of points that are relatively close together, maybe seem to be in a pattern, then there's one that's maybe far off to the right or way above, and those points are called outliers. And usually when we're doing a regression line, we won't count them simply because they can skew our prediction a lot. The example I always give is if you're maybe looking at incomes for families, and you want to maybe generate the family income, and it just happens that Bill Gates' family is one of the families. Well, this family's got an income of 50,000, this one has an income of 75,000, and then this family has an income of 3 billion. And of course, if you were to include the Gates family in that, it would make our prediction so off that it wouldn't be particularly useful. So if you have any values like that, they're called outliers, and we usually leave them out. If you're not sure that something's an outlier, I would include it, and you should never have more than one or maybe two outliers. Because again, anytime we're excluding data, we want to make sure we're not giving up information that we should be paying attention to. Alright, so we've got our information ordered. Usually we're going to look at doing that in a table, but again, you could do a scatter plot. And after that, we're going to divide our data into two equal sized groups. So if you have an even number of points, that's easy, the lower half and the upper half. If you have an odd number of points, so you're going to have one extra value, and you're going to have to try and feel, well, should that middle value go with my bottom group or go with my top group? It's not a big deal whether you which group you put it in. Usually I'll try and put it in the one that's kind of has closer x values to it, but other times it won't make a difference at all. So once we have it into two groups, we're going to find two new points called M1 and M2. And we're going to do that by basically finding the mean or the average x-coordinate and y-coordinate. So to find M1, we're going to look at, well, what is my average x-coordinate for all my points in my first group? And that average value will be my x-coordinate for M1. And then I'm going to find, well, what's my average y-coordinate for all my values or all my points in my first group, and that will become my y value for M1. And then, go figure, we're going to do it all again for group 2. Our average of all our x values in group 2, that's the x-coordinate for M2. Average of all our y-coordinates for group 2 will be our y value for group 2. And we're going to look at an example so you'll be able to see what all that means. Not particularly complicated. Now, after we found M1 and M2, we're going to find the equation of the line that would go through those 2 points. So again, going back to when we looked at functions, to find the equation of the line, we need to find the rate of change. And since we have the coordinates of both points, that won't be hard to do. And then we'll use our rate of change to find the initial value, y equals ax plus b. And that equation, the y equals ax plus b, is the equation of your Mayer line, and that's basically the line that we'll do as a regression line to predict our value. And then the last step is we're going to use our line to find the value that we want. So usually you're either maybe given your x value and you're asked to make a prediction for y value, or perhaps the other way around. And so we're just going to take the x or y coordinate that we know, put it into our Mayer line equation, and solve for our unknown variable. So let's take a look at an example. Alright, so our table below shows the percentage of pain reduction for chiropractic patients in relation to the number of days since the start of treatment. And then we're asking how much pain reduction do you expect if you were to undergo treatment for 50 days or 100 days, and how long would it take you to expect to have 50% reduction in pain level. So this makes sense. I mean, if you go to a chiropractor, you're probably having some level of back pain or maybe neck pain, and of course you want some of that pain, or ideally all of it, to go away. And when you were to first sit down with your doctor, you know, he's going to want, or she's going to want to let you know, what you should be expecting. And so, of course, every patient is going to have slightly different results, but you could use a Mayer line to get a pretty good prediction as to, what you should expect going into your treatment. And then again, from there, you could get an idea as to, okay, well, if I'm going to be going in treatment for a certain period of time, how much, pain reduction should I experience? Or conversely, maybe you're like, I want to make sure I have half the level of pain that I have now, and well, how long should that take me? How much treatment should I have to do? So all kind of ways that can let you get a good idea before you would undergo your treatment as to whether it's going to be a good treatment for you to get you the results that you're looking for. So if we look at our table here, it's actually divided into two tables, but it's really one. Top is our x-coordinate. We always put our x on top or on the left. And it shows the days since we started treatment. So again, I commented earlier, we have to order it from lowest to highest. And this table is already ordered that way by our x variable. 5 and 7 are lowest values at the start, and then our highest values, 84 and 90, at the end. And then our y-coordinate, or our y value, is showing the percentage of pain reduction reported. And that's put in the bottom. The other thing I will note is we've got a couple points. For instance, we have two people, or two different patients in this particular case, that have had treatment for 30 days. And when we're organizing their y-coordinates, we go from lowest to highest again. So of course the x-coordinates are the same, we're still going to go from lowest to highest. And again, the same idea down here. And when we look at this data right off, we can see there's probably a general pattern. As people go up in the number of days of treatment, their pain reduction also seems to go up. That makes sense. The people that have only had a few days, their pain reduction's relatively low. The people at the top, they've had a substantially higher level of pain reduction. But we'll also notice that it's not perfect. Like here, this person's had more treatment than the person with 16 days had more treatment than the person with 12, but they're reporting less an improvement or less pain reduction. Here we've got two people with the same amount of treatment with different amounts of pain reduction, and so on and so forth. So we can see it's not a perfect connection, and that's really when a regression line becomes handy. It lets us to get a prediction when things aren't a perfect match. So let's go through our steps here. So So our first step is we need to identify. So we need to identify it as a regression line question. And probably the best indicator of that here is that down here we're being asked to make a prediction. How much pain reduction should we expect? Again, it's not saying it's perfect, but it's giving us an overall indication or an idea. All right, and so I'm gonna cut out all the reading, all the letters here, so we can just focus on the table. Gives a bit more space to work. So our next step is we have to order the data, or you could create a scatter plot. Again, I'm not going to do a scatter plot on this one just because of the time. But if you're a visual learner, I highly recommend it, or especially if for the first couple times, it's really good to do a scatter plot so you can see how everything fits in. And usually people find that helpful. But our data here is ordered from, again, lowest to highest value of x. So again, it's a relatively easy thing to do, so I thought we'd just do an example where it's already done. But if that's not done, that's your next step. After that, we're going to divide the data into 2 equal groups. Again, that's actually done for us as well here. We got 7 points on top, 7 points on bottom. The only time it becomes tricky is if you have an odd number of points and you'll have to figure out, well, where should I put my middle point? And just to give you an example, like let's say I had another point that would say somewhere between 30 and 41. Well, if I had a value of, say, 32 or 33, I'd say, hey, that's closer to 30, so maybe I'll put it in this top group. If it was maybe 38 or 39, all right, that's closer to the 41, and I put it in the bottom group. So not really a rocket science there, just doing your best job and making the best choice you can. All right, so the next piece we have to do is find the mean points. It's called M1 and M2. So I'm going to look at the first group here. I'll highlight it. So our lowest half, and I'll do that in green. That way we can just kind of match things up a little bit. And then we're going to do our bottom, or actually probably it's on the bottom of our table, but really our top half in terms of the higher values. And I'm going to do those ones in yellow just so we can match them up. So we're trying to find our M1 value. And so I'm just going to leave that. Go M1. And to do that, we're going to find our average x and our average y. So to find our average values, I'll put it over here, we're just going to have to take our values of x and add them up. So we got 5 and 7 and 12 and 16, 21, and then 2 30s. And again, it's really not hard to do that, but if you had a whole bunch of points, if you have 40 or 50, it could be time consuming. And in statistics, one of the places that people are most common to make mistakes is just in punching in the values wrong. Maybe you accidentally hit multiplication or you miss a value. It's really easy to do. So I'm going to recommend that you do things a couple times to check it over to make sure it's consistent. So we add them up, gives us a value of 121. And then we've got 1, 2, 3, 4, 5, 6, 7. We've got 7 points, so we're going to divide that by 7. And that gives us an average x value of 17.29, or I'm going to say 17.3. Probably doesn't make much more sense for us to go much more precise than that, given our value up here. And then we're going to do the same thing again for our y values. So I'm going to go 5 and 6 and 12. And 8, and 13, and so forth, 17 and 21. And that gives us a value of 82. And again, we'll divide by 7 to get the average. And, oops, pardon me. And so our average is actually right here, 11.71. So I'm just going to go with 11.7. It's a little bit messy. I'll clean up a bit. And so our coordinates of our first point then is 17.3 and 11.7, and I'm just going to put that in green just so we don't matches up. And now, just as exciting, we're going to do the whole thing again, only this time we'll look at, we'll look at our M2 point, and M2 is just going to be the same thing again, but for our second group, so for the top half. And bring out our calculator again and clear it off. 41 and 60 and 65. So again, we're just adding up our x coordinates and then dividing again by 7 to get the average. Now, a couple of things I will mention. when you do this, make sure you hit equals first after you add them all up. Otherwise, it'll just divide the last number by 7. We don't want that. And if you've got a bunch of multiple values here, we could have put like 70 times 2 rather than 70 plus 70. Not particularly useful in this case because there's only a couple. But if you had, maybe 5 or 6 70s, it might make more sense to put, 70 times 5 rather than 70 plus 70 plus 70. So on and so forth. So our value here is 68.57, and again we'll just go to one decimal. So 68.6 is our average x-coordinate for the top group, so that becomes our x-coordinate for this M1 or M2, pardon me. And then we'll do the same thing for our y's. 27 plus 31, equally as exciting when we do it with y's. Again, statistics, most people find them relatively boring, but the good thing is they're not particularly difficult because we have to follow the steps properly. So we have a total of 276. We'll divide by 7. Gives us an average of 38.3. 38.3. And again, I'm just going to mark that with yellow so we can see what matches up. So those are our M1 and M2 points. And our next step, we need to find the equation of the line formed by M1 and M2. So if I had those 2 points, what line would go between the 2 points? So when we do that, first thing we need to do is find our A. Actually, remember, whenever we have a line, we've got form of y equals ax plus b. Sometimes people use mx plus b. We always use a in this case, no different. And our A represents our rate of change. And I'll put out a rate of change formula here, y2 minus y1 divided by x2 minus x1. You may also do delta y over delta x, or rise over run. There's a couple different changes there. And now we can just go put in our values. And well, we don't even really have to worry about 2 and 1. M2 will be our second point, and M1 will be our first point. So we just, again, fill in our values. Y2 is 30, so we have 38.3. It's going to be, maybe this might be a little bit sloppy. I'll try and do the best I can. 38.3 minus 11.7. And we divide that by 68.6 minus 17.3. And again, we'll need our handy dandy calculator again. Clear this off. 38.3 minus 11.7. So we have 26.6. I'll write that in. And then in the denominator, 68.6 and 17.3. 51.3. And now we divide them. So 26.6 divided by 51.3. And once again, it gives us this very long repeating decimal. I'm just going to go to 2 decimals, so 0.52. And again, to go too precise with it doesn't really make sense because we know it's not going to be a perfect prediction anyway. So our value of A is 0.52. Now we've got to find our initial value, or B. And to do that, we can go back to our equation. But now rather than writing in A, I'm going to write in 0.52. X plus B. And since we want to find out B, which is our initial value, or our y-intercept, I need to know X and Y. Well, do we have any time we know X and Y? Absolutely. We can use our coordinates for M1 or our coordinates for M2, and it shouldn't matter either way which one we use. I'm going to go with M1. So I'll fill in 11.7, which is our Y value, 0.5. Now one thing that you'll notice when you're doing a regression line is you often don't get like nice round numbers. So we're going to have a lot of kind of decimals here, and a lot of people don't like that. I don't blame you, but it's just kind of the way it is. Again, because we're getting a prediction, everything's not precise. In statistics, it's common that you'll get numbers that aren't round. All right, so we bring up our calculator again. So I get 0.52 or 0.52 times 17.3. That's 8.996. Well, we'll just make that 9. So we've got 11.7 equals 9 plus b. And then subtract 9. Whatever I do to one side, I do to the other. And let's flip it around here. So b is going to be 2.7. So our regression line formula then will be y equals 0.52 plus x, pardon me, plus 2.7. And that's usually a good idea. We can check it using our M2 point. So I can put in 0.52 times M2, or the x coordinate of M2, 68.6, and then add on the 2.7 and 38.37, 38.3. Again, it's off a little bit because we've been rounding, so no real big deal there. And then our last step is we're going to use the equation to find our wanted values. And all right, so what are the wanted values that we had here? Well, we were asked three things. We were asked what level of pain reduction could we have after 50 days. So let's start with that first. We'll look at our 50 days. And well, 50 days, well, that represents our x coordinate here. Again, we can go up to the table. We put it on top. I guess maybe I could label in this here as x and this here is y. So for 50 days, I'm going to take my formula and I'm going to fill in 50 for my x value. And then we're going to solve it out. So slide the calculator over here this time. So we've got 0.52 times 50 plus 2.7 and 28.7. So for 50 days treatment, you could expect 28.7% pain reduction. And if we go up to the table again, we can take a look. Well, 50, where's 50 come in? Well, somewhere in between here. And again, our value 28.7 is almost right smack dab in the middle of these two values. So that seems to fit pretty good. If we want to look at 100 days, again, same idea. Only here we're going to use pardon me, we put an x value in of 100, and this one will be a little bit easier to do because 0.52 times 100 will be kind of easy to do in our head. So we'll put it in. Remember, for multiplying by 100, we just move our decimal 2 to the right, so we have 52 plus 2.7, and that gives us 54.7%. And again, we can go up here and we can say, well, this person here at 90 days, they have 54%. So they're actually maybe doing a little bit better than we might expect. Now, one thing we need to be careful about, you notice that our 100 is kind of going off the charts here, out of the side of the data. And you got to be really cautious about doing that with a Mayer line or with any regression line. Usually we want to try and focus our predictions from within data that we know. And that can get a little bit tricky. For instance, if we were to kind of continue on with this pattern, if you went for say 300 or 400 days of treatment, it's probably going to give you a pain reduction above 100%, which obviously doesn't make any sense. So usually it's best to stay in or very close to the data that you have. Again, if we were to do maybe 4 or 3 days, that'd be fine. Probably wouldn't go too much above 100 days in prediction, because otherwise our values are going to kind of get a little bit out of hand. And then the last one that looked at was, well, how long would it take for us to expect to have 50%, oops, pardon me, 50% reduction. And in this case, the only difference here is that the 50 refers to our y value. So again, I'm just going to put that in for y. 0.52 x plus 2.7, and so we subtract 2.7 from both sides, and we get 50 Whoops. Sorry for that. Getting a little sloppy. So we get 50 minus 2.7 is 47.3 equals 0.52x. And since we want to just get x by itself, we divide by 0.52. And whatever we do to one side, we do to the other side. So scroll down here a little bit so we can put in our answer. And bring up the calculator. 47.3 divided by 0.52 gives us 90.96. So we're going to be about x equals 91 days. So on average, we should expect to go for about 91 days to get 50% reduction. And again, we see this person maybe did a little bit better than expected. They went 90 days and got a little bit higher. So there you go, a long one, but hopefully that helps you with regression line, a very helpful tool. Thanks for watching, guys. Have a good day.
You're still here? It's over. Go home. Go.